Hello everybody, welcome to the Integrating Scratch webinar series, the second session. This is Haruna, and hello everybody.
Hi all.
Nick, and
hi.
And today's agenda, just based on feedback from last week, we're going to start out just going over the overall scope of the course, which we probably should have done last week, but we somehow didn't. But we'll go through, where we are and where we're heading from here. We'll talk a little bit about classroom management in Scratch, which was also raised by some people on the survey. We'll show some examples from week 1 homework, and we are going to go into the new material for this week, which is working with sprites. So overall scope, last week in session 1, we talked about backdrops, just the background, and how to change them and how to use them using weights and loops. We also did sound. This week, we are going into sprites. And sprites are, again, the characters or the objects that are in your program. So there are different ways to use them. We're going to get into all the different movement commands and how to change their appearance. Session 3, we'll get into more programming with if-thens, which are conditionals, and something called broadcast, which is specific to Scratch, but we'll talk about it on the 3rd session, and which lets you add more interactivity to the program. So you can do things like, when you click on a certain thing, what happens, or you can start getting more interaction with the users. And then for the final session, Rashmi is going to show us some really cool programs with math. And get into things like fractals and getting user input, so like having users input numbers and have that be a part of the program, so on. So that's where we're headed. I know last week some people felt like what we were doing last week was easier to do in PowerPoint or Prezi, which I completely agree, but we are heading on from here and expanding on that, so don't you worry. So Rashmi, do you want to talk about the classroom management piece?
Sure. Thank you, Haruna. Just in terms of, there are several ways of looking at your classroom management. So if you have older students, it is highly recommended that they create and manage their own accounts on the Scratch website. For younger students, we recommend that the teacher creates the accounts and then the students upload the projects. Also, the third option is create one account, share the account, and that's sort of for the group. So if you have small groups in your classroom, you can do that. So that's a really great segue to our third option in terms of classroom management. We highly recommend curating projects in a studio. So if you have a small group, make sure certain projects are up there for great exemplars or showcasing. And we'll look at a few that we've put together that showcases some of the objectives you want to achieve in the project. There is a teacher platform that is in the beta stages. Maybe at some point we can show how that looks, but that's...
Yeah, it's still in beta. So,
right.
Yeah.
Absolutely.
If it does become available, we'll definitely share it with you. We still don't know what it's going to look like.
Absolutely.
But a lot of educators have been asking for some sort of teacher platform that lets teachers keep track of student accounts and student projects, and we believe it's going to be some form of that.
Sounds good. Thank you.
Scratch has certain guidelines of being a responsible user, and I just want to go over some of those policies. So one is the Scratch community guidelines, and the other one is the remixing. So I'm going to shift screen for 1 second. So these are the community guidelines. It's right in the Scratch website. Because once you share a project, Scratch is in public, there are some guidelines in terms of be respectful. You don't want to, put any comments that are not respectful or constructive. Keep personal information private. You want to make sure when you create a project, you don't include any sensitive information in there. And overall, it's supposed to be a friendly site. Going into the other piece about the remixing. So remixing is a term used for taking somebody else's Scratch project and modifying it, which, according to Scratch, is very it's okay to do. And they require that all shared projects be remixable. So you can't say, oh, I don't want anybody editing my project. That's their whole spirit. They want everything to be open source, and that's also a good way to learn programming. And because Scratch was made to be an educational software, they don't want to stop that from happening. Another piece I do want to point out is, can I use images, sounds, media from internet in my project? So it is important to give credit to the original creators, and it's also important to use things that are legal to use. So if it's any sort of copyrighted material, we need to be aware of that. And they do suggest you look at the Creative Commons page to check out the guidelines for that. So this is a Scratch studio of the homework projects that you've submitted. And if you have just submitted in the last hour or two, I hadn't had a chance to add it onto here, so don't worry, we still have your projects, we just have not had a chance to add them. Anybody can make a studio by going into My Stuff and say New Studio on the corner here. But I already have a studio, so I'm going to go into my Teacher Projects. And once you have a studio, you can add any shared projects by clicking on that button and pasting the URL there. So the couple of projects I did want to share, the first one that was submitted, and this is by, I believe it was by Errol Knoll at the Winship. There. So it's a project about walking to the public library. And the reason why I wanted to share this, I thought it was a really cool project, was that it integrated Google Maps and Google Street View. And I think there's sound going on. So it integrates Street View, and it talks about how to get from the school to the public library, which actually has like a little bit of parallel with the whole coding concept. When you're giving directions to walk from one place to another, you have to give very specific instructions, which is exactly the same with coding. You need to be very specific with your instructions. So activities like this, like coming out with the directions to get from point A to point B, is actually a really good pre-coding activity. So this could be something like a pre-coding activity you do with students that then moves on into the real coding activity. So I thought that was really interesting. The other thing I did want to point out is it does give Fixture Credits at the end, which is very nice. And you can also include notes and credits on the side on the project page when you share a project. So this was a project done by Violetta at the Horseman. It's a very simple project. It's called Spring is Here. It's got a lot of music. And it does, she drew her own drew her own backdrop. I'm going to wait till the backdrop flips. But I just like the simplicity of it. With, it describes several different things that happen in spring, which can be like a really nice ELA project for kids to come up with different ideas for a certain topic and just have a slideshow with different words or different adjectives and have artwork that describes each one. And so you can integrate ELA and art and coding all at the same time. So I thought that was a really nicely done project. Do you want to talk about this one, Rashmi?
Sure. Thank you, Haruna.
Should I play it?
We don't have to. I think the most important part I felt that I wanted to share about this project was how the notes and the credits were structured. And Haruna mentioned this before about how remixing is a great aspect of Scratch, which allows you to look at different programs and then integrate into creating one unit. And that's how programming works. It's also in the notes and credits, you can see that all the sounds, all the media is sort of addressed in a Creative Commons structure, which is another thing that Scratch advocates for, and it's a really great practice. So keeping that in mind, it really gives credit to the author of the original program as well as any media that's shared. Thank you.
And this instructions and notes and credits section of the project page is you can always add any information in there. So if you were making a program that you want your students to use as part of the lesson, you can put instructions on it, you can put additional links on it, additional resources, as well as the original source. And the students can go to those links. And then, so now I guess we're ready to move on to this week's topic, which are sprites. So this is not a project that we made. This is something that we found in Scratch. So I'll just play it.
And Zeus by Fatima and Tahir, grade 5.
Let's play it.
Yeah, I think it's playing.
Okay.
Yes, fine.
Yeah.
There once was a queen bee who visited Zeus, king of the Greek gods. She asked Zeus if he would grant her a wish, and since he was happy, he granted it. Oh, Master Zeus, will you please grant me a wish?
Of course you may have your wish. What is it that you desire?
All right.
It's a really great example of how you can integrate English language arts into a curriculum. There is a lot of writing happening. You see the sprites moving across, and we'll obviously get into a lot of what sprites are and how you can get them doing or programming things or programming sprites into the Scratch environment. But overall, as you can see, it's a fifth grader in a technology classroom that is integrating curriculum in an English language classroom. So that in itself is a really strong connection.
Yeah, and this is this is sort of an extension to what we did last week. Last week we did the backdrops, and in this animation too, you see the different backdrops changing from the title screen to the next screen and so on. But we also see an additional sprite, the moving piece. And that's what we're going to be working on this week, is to add that a little bit more movement. And you saw the speech bubbles coming out of these things, and that's we'll show you how to do that as well. This is another one that we found, and it was done by somebody for an English class. And again, similar, just pay, this one has a slightly, one more clickable element, but again, it's, backdrops and some moving elements, which are the sprites. So just, what's happening right now? Okay. So those are the type of work that we'll be doing this week.
Also some integration of music into the existing parts.
Yeah. And like for this page, the lightning bolt is actually a sprite, it's an object. It's not part of the background, but we will definitely be showing you how to do some of those things as well. First, we will talk about sprites. So I'm now in my Scratch editor. Again, sprites are objects or characters or anything that you need to either move or manipulate or make it disappear, or any kind of object that needs to do those type of things will have to be a sprite. Anything that can't be part of the background is a sprite. It doesn't necessarily have to move. It could be a text. It could be, it could take any form, but it's something that cannot be part of the background. So by default, you start with one sprite, which is this cat. But you can always add a new sprite. There are 4 ways to add a new sprite. You can add one from an existing library, and they have quite an extensive library of very random objects.
Yes. Donut.
Anything from realistic-looking fortune cookie to a very strange ladybug to flying carpet. So there are tons of different things you can choose from. I am going to choose a penguin. So now I have 2 sprites. And you can move your sprites around on your screen by just clicking on them and moving them around. Another way to add a sprite is to make one. So you can click on the paintbrush and you can make your own sprite. So let's say I just wanted to have a circle. And that would be my sprite. Now, anytime you're making or editing a sprite in this editor, you need to kind of pay attention to where the center of the sprite is. And that's done by this crosshair here. So if you click on this crosshair, you get a crosshair, and wherever you place this this crosshair is going to be the center of your sprite, and you get centered on that. Now, the reason why that's important is whenever you move a sprite or rotate a sprite in Scratch, it's going to do it around the center point. So you just need to know that that's the center, because if my center point is located outside of my physical sprite, physical drawing, then it's going to start behaving really strangely when you start moving and rotating the picture, because everything happens around that center point. All right, so that could be a sprite. The other way is to upload a sprite from file. So just like you uploaded backdrops, you can upload sprites if you have any image file. Well, not any image file. You need to have either JPEGs, PNGs, or SVGs, which I will talk about a little bit more at the end. You can also import a new sprite from camera. So you click on that, and it's going to ask you if you can access your computer camera. And if you say yes, you will see your image. You can take a picture, and that could be your sprite. And anytime you have a sprite, so now I have 4 different sprites added in 4 different ways. You can go into the costume tab on top, and just like you had multiple backdrops for a stage, you can have multiple costumes for a sprite, which means, so actually let me go back into the cat. The default cat sprite has 2 costumes already built in, and that's just a different appearance of the object. So you can have this cat put on either costume and have different looks depending on your program. And the same thing, the penguin only has 1, the sprite, this one only has 1. But I could always say duplicate, and let's say I want a red version of this. Then I can have so I could have a clear circle and a red circle for different costumes. And why we want to do this, we'll talk about it a little bit later when we talk about manipulating sprites, but just know that they could have multiple costumes. So I think now we're ready to get into motion.
Yeah, we are.
Okay, so I'm going to switch the screen over to Nick, and he will show you all the motion scripts.
So hello, everyone. Okay, so I'm going to show you guys how to use some of the motion scripts that are, or motion blocks that are associated with Scratch. I'm going to go to the real basic ones first. So I'm going to go ahead and share my screen with you. I'm going to come over here to my project that I've been working on. Okay, and so you can see I have, this is the backdrop that I used last week. And this particular project I was going to show how to use the simple past tense, but I wanted to use motion to define my sprite first. And as you can see, I've already made my first sprite, and you can see I didn't choose from the library. I didn't paint it, but I actually took a picture of myself. I could have uploaded it if I wanted to, but I took a picture of myself before this, and I decided to use that as my sprite. So here I am, and so this is my sprite. Right? I'm going to show you the different ways to move. Right? So the ones I'm going to focus on are move 10 steps, the go-to coordinates, glide, set Y to, and set X to. Okay, now, the first thing we have to...
Wait,
sorry?
yeah. Go ahead. Sorry.
Okay.
I forgot to talk about the coordinates.
All right. So I'm going to go to the coordinate grid really quickly. So before we understand how to move within Scratch, you have to have a basic understanding of the X and Y axis, right? X being horizontal line and the Y being the vertical line. How she used the crosshairs in the beginning, and that's why it was so important for her to center or get the crosshairs on a drawn sprite, because Scratch is actually working with coordinates to move things around. Okay. So with the first type of movement, it's the most basic is moving steps, and you can, right here we see it moving 10 steps. Now I can change this if I want to. I could move 20 steps here for the actual program that I wrote. But when you see movement of 10, it's going to show the center of my sprite is going to actually move 10 steps within the coordinate system. So if we look, let's go ahead and make it bigger right here. So it's actually going to move 10 in direction. So it's on the x-axis. So it's going to be, it's in the middle right here. So I'm at 178 on the x-axis and 61 on the y-axis. It's going to move 10 to the right on the x-axis. So this is going to cut, this 178 is going to turn to 188.
Before we get too deep into that, can I just show them the coordinate real quick?
Sure.
So I'm going to steal the screen for a second.
We're going to take it back really quick and show you some of the coordinate grids.
This similar figure is inside your one-pager. So the stage is 480 across and 360 high, with the 0, 0 being in the middle. So that makes it go from negative 240 to positive 240 on the x-axis, and then negative 180 to positive 180 on the y-axis. Okay. And if you ever forget this, that's okay. I don't remember it either. But this figure is inside your one-pager that we did for week 2.
So okay, so moving 10 steps would just be moving 10 steps, I guess, on the on the x-axis. Okay, and then you have the more definitive movement, which is go to the x-axis 168 and the y-axis negative 135. And you'll see how that goes. And you'll see how it's just going to move from one place really quickly, and then it's going to go to the other. The glide shows a movement of 3 seconds to actually get to the negative 180 x-axis and positive 35 y-axis. And then you would have set y to 60. So from wherever the sprite is, it's going to go positive 60 on the y-axis. And then the last command is going to set x to, I'm sorry, it's going to travel on the x-axis to 180. I'm going to show you what this all looks like in one big step. So here's my sprite right here. Whee! Right? Here it goes. And I'm going to start this event by clicking on the green button. So as you can see, it's going to show. So first, it went 20 steps to the right. You see on the 20, and then it's going to go to 168.35. And as you see, it went down. And now it's going to glide for 3 seconds to negative 180 to and y35. See how it's gliding? Right? Then it's going to go positive on the y-axis to 60 or 60 steps, and then it's going to go back to the x-axis. I'm sorry, yeah, x-axis to the right at 180. So these are all the different types of movements, and you can see that I put a wait block in between all of them. And so in order to show you that, in order to explain to you what was happening, I put this wait block in between. So again, this move 20 is relative coordinates, and so it's wherever the sprite is, it's going to move 20 steps. And these ones, these blocks that are more defining with the x-axis and the y-axis, they're actually definitive. So they actually go every time wherever the sprite is, they will go to these coordinates. So really make sure you understand what's happening right here with the x and y-axis, because that's going to be able to show you the different ways your sprite can move. Again, let me show you this again all in all without explanation.
And all the motions other than the glide happens instantaneously.
Right.
So if Nick did not put those weights in there, they will zip around the screen so fast that you will only see the ending position, the very final position it ends up in, except for the glide one that actually lets you go slower.
Right.
So here it is again. Here's just the movement. Move 20 steps. Now it's going to go to 168, negative 35. Now it's going to go to negative 180, y35. Can move positively up this y-axis at 60, and positively in the x-axis to 180.
And as you can see, the wait times are literally 2 to 3 seconds, so you can change that and see how your simulation works.
And I'm going to give back to Haruna. She's going to explain the random number blocks to you and looping.
Okay. Sorry about that, people, everybody. So my apologies. My screen should be full now.
We're just going to backtrack, everyone.
Yeah, sorry about that.
Sorry about that.
You can right-click and delete, or you can click on the scissors up top and snip it off. You can also right-click and duplicate if you want to duplicate any sprite at any point. So back in here, we talked a little bit about, so we have I just dragged out a bunch of icons that Nick already talked about, and then we went on to the turn, which is to turn, and I'm just clicking on these to demonstrate how each one works, but you can turn them.
And also the random.
Or there is point in direction. I know I didn't do this yet, but you can change the direction that it's pointing to by using this rather than just turning by 15 degrees or so. And we did the random numbers. So the random numbers are, again, under operators. It's this green one right here. And you can select a range for the random number to occur in. And then you can drag this into anywhere you see a number input. So you can drag it right in there. And the blocks will resize itself. And then now we're going to talk about how to use repeat in a movement. So let's say I want my cat to start over on the left-hand side. So when I click on the green flag, I want the cat to go to negative 195 and 0, which is actually where it is right now. And then I want it to go to the other side of the screen. So if I just say go to positive 195 and 0, It's just going to happen so quickly that you don't even see the beginning point. It's super fast. It happens instantaneously. But instead of doing that, if I say repeat 470, and then I'm just going to say change x by 1 each time. So it's going to do a repeat, 470 times repeating, moving by 1. Then it actually slows it down. So now you're kind of simulating the glide to command, but you're doing it, I guess, manually. Now I can then control the speed of this. Let's say now instead of changing x by 1, I'm going to change it by 10, but then I'm going to repeat it less times. So now it goes a little faster. And then what we can also do is something like we can change the y at the same time. So now it's moving diagonally. Or we can start doing things like change its size. So I'm kind of jumping around by going into the looks menu. We'll talk about more about the looks menu later, but there is a change size by command. And by default, everything starts at 100% size. But I can say change size by -1, and now it shrinks. And actually now I have to reset the size to 100%. So now you can see it shrinking, and it kind of gives you the effect that it's moving farther away and getting smaller. So if you're making an animation,
That's useful.
Using this repeat to slow things down rather than using glide will give you more control over what happens between point A to point B. So these things are very specific to Scratch. One of the things I want to show is if on edge bounce. And what that means is it defines the behavior of the sprite when it gets to the edge of the screen. So if I put this as part of my, I'm going to first show you what happens if I don't put it in. So let's say I make this number so big that the cat runs off the screen. Then it kind of stays there. It doesn't really go away. It stays at the edge of the screen. But if I say if on edge bounce, and that's kind of on or off thing, you can say it at the beginning of the program and it'll keep that behavior. Now, why is it not bouncing? Oh, because I did X and Y. Sorry. Try one more thing. Okay. Okay, so now, on edge bounce. Why is it not bouncing? Sorry. I'm not really sure why it's not doing it right now.
It will. It will.
I'm very, very confused, but it is not doing it right now, but it's supposed to. Bouncing now.
Do you want to put it at the bottom of the repeat?
It seems like it's bouncing now, though. It's changing directions. Well,
want to put it at the bottom of the repeat and try?
Maybe. Yeah, let's try it here. Oh, there
we go. Sorry, it needs to go inside the loop.
Okay. So now it bounces around the screen. Sorry about that. And if I don't have this, it just kind of stays on the edge. Another behavior that is very specific to Scratch is the set rotation style. There are 3 different options: all around, don't rotate, and left and right. All around means, just like you saw with the cat, as it bounces, it changes, the cat's orientation changes. It rotates all over the place. If I say left and right, I'm actually going to take out this change size by it because it's hard to see when it's too small. If I set the rotation style to left and right, then when it bounces, the cat stays upright, but it just switches appearance from left to right. So it's still changing directions, but just the looks of it stays upright. And if I say don't rotate, then it's actually not even going to flip left to right. It's just going to stay in one orientation. So this, depending on what kind of sprite you have, if you're using your own photo, then maybe you want to just make it don't rotate. But if it's a cat, you can make it go left and right, or if it's a ball, you might want to make it rotate all over. It's really up to you and how you want the sprite to look. So we showed the costumes earlier. So again, with the cat, we have 2 different costumes. And under the looks menu, which I showed you just a set size to, but there is something also called next costume or switch costume to. I'm just going to pick next costume and stick it in this loop once again. So now every time I click this, throw some of these away, clear my screen a little bit. So now when I start the script, it will set size and then set rotation style. I'm going to say left to right again. And then for 100 times, it is going to move 10 steps and then switch costume to the next costume. And what you'll see now is it flips back and forth between one costume to the next, which gives you the illusion that the cat is walking or running really fast.
And bouncing.
Yeah, and that's another advantage of using repeats to move the things. You can change the costume and give it a more fun look. And a lot of the built-in sprites have 2 costumes already built in, like this cat, or some of them have more than 2. So you can check out some of the built-in sprites and see what you can do with the costumes. You also see that there is a switch backdrop block here, which is exactly the same one that you used last week. So you can switch backdrop from a sprite, not just from the stage. And that way it's easier to synchronize what happens between the sprite and the backdrop. Oh, we need to talk about the say. So there is a say command. This is what the speech bubble was from the example that we showed. Let me show that again. So cat walks for 10 steps and then says hello for 2 seconds. So this say doesn't actually produce any sound. It's just a speech bubble. And sync is very similar, but it's just a different shaped speech bubble. Right. And you can make it say something for a specific number of seconds. So if you have a longer prose, you can make the time longer. Or you can just have it say, and then it'll stay there indefinitely until you actually
the next command.
Put a say command with a blank inside. Then it goes away. The same thing with the think.
Back here, and I was showing the different sprites within my particular project, and I know we're focused this time. We had some ELA projects going on. Here's just a simple way I made an a way to make an ELA project using the say command. So all I did was I got, I went to the regular say command and I filled it in with different types of text and different prose. And so, like for example, I have, I'm going to go ahead and my first one talking about George Washington. So I would just insert it above. Actually, it's gonna, I'll insert it right below the move. Each of the move blocks. And you'll see once it comes up, it takes on. The project takes on a life of its own with no said speech or said text on in the project. So I'm going to go and play it again. So George Washington was a general during the American Revolution. And it's going to go through 8 seconds, unfortunately. George Washington became the first president of the USA, and 8 seconds later. And you'll see.
And you can also, time your backdrop
exactly.
to change at the same time.
Right.
George Washington supposedly had wooden teeth, which.
2 seconds.
And George Washington lived from 1732 to 1799. So easily made into an ELA project using the simple past, using say and using past history. Or history.
Yeah, or history.
Yeah.
Or both.
Or both, right. So yeah, that's just one of the things I wanted to show using the say command. You can take it.
So while you're on the screen, do you want to show and hide real quick? So this is the looks menu. This is the looks menu. And there is also a show and a hide, which it's pretty self-explanatory, but if I click on hide, it goes away. If I click on show, it comes back. So you can also, spread this out throughout the program if you want the sprite to somehow disappear at one point and have a different sprite appear, or if you have multiple sprites and you want specific ones to appear at different times of the project, you can show them and hide them. Just know that when you hide them, the next time you start the project, it's not going to automatically show up. So you need to put show at the beginning of the program to make sure it definitely comes back out at the beginning. If that's when you want it.
And this is again really useful when you're programming your game. So you probably see some of the examples later on.
Right.
So we covered most of the motion commands. There are a few things that we didn't cover, but that's okay.
Feel free to play with them.
Feel free to play with them. We
Absolutely.
did a few key things in the looks command, but again, you can definitely play with them. The color effects, graphic effects are pretty fun to play with, and you can definitely play with them. And I'm going to show you the pen command, which is it basically puts a pen right on your sprite, the center point of the sprite, and lets you draw lines on the screen. So I am just going to very quickly say pen down right at the beginning of the program and pen up at the end.
Right.
And it's important to pen up whenever you don't want a line, because otherwise the pen just stays down. So now if I play this, you don't really see the first line because Nick's sprite is a little too big.
My face is big.
But you see, it's a little bit hard to see, but you see the blue line right there? So it went 20 steps to the right, and then it went to the new coordinate, and then you'll see the pen drawing along as it glides across the screen. And you'll keep on seeing that. And you can change the color.
Right.
You can change the size.
Could add that.
You can change the size to make it a little bit thicker. And you can actually also clear the screen to make sure everything goes away at the beginning. So when you restart the project, you obviously don't want this old line to stay there.
And you have a nice little quadrilateral there.
Yep.
Yes. So pen is actually really useful for math projects. If you want to draw polygons or anything like that, it's a really nice addition to math projects.
Right.
Or if you run that one more time, it cleared the screen, and then it put the pen down, but I changed the pen size to 4, so now you should see a thicker line when it plays. Yeah.
There we go.
So now you can see the line a little better. So again, this is something you can definitely play with. Just know that the 3 important ones are pen up, pen down, and clear. And again, this is really, really useful for math projects, among others.
Right.
You can also do things like if you have a world map as your background, you can have it travel, you can have a sprite travel from one country to another.
And measure.
Yeah.
Yeah.
There's a lot of stuff you can do with that.
Definitely the fractals.
Well, I know we went through a lot today, but
I know, it's a lot of stuff.
But you can do so much with it, and it's good that this is recorded because you can go back and access it anytime you want, and rewind, and fast forward, and all that jazz.
Absolutely. And play around with the different commands that are not yet covered, because it's fun. Experiment with them. As long as you put it in, change around some variables, it allows for that. Variables we are covering next time.
Yes, variables we'll get to.
Next time.
So
Sorry.
for your homework, once again, it's a 2-part homework. One is a quick little exit ticket, and that's really important to us. We take those feedback seriously. And your Scratch assignment is to create a program with at least 2 backdrops and at least 1 sprite that moves around. You can add to your week 1 project, and I think for a lot of them I saw some really good extensions that could happen. Or you can start from scratch, no pun intended. You must have some sort of motion, and I really encourage you to explore different ways of motion and looks. Sound and pen are optional. So if you already have sound built in from last week's, you can just keep it in there, or you can add to it. Pen is definitely optional. I know we have some math teachers in there. If you want to, play with making polygons and things like that, it's a great way to use the pen.
Yeah, and we can explore it later too in the later assignment.
And Rashmi's doing one whole session on that, so we'll definitely start exploring more of that. And then once again, you're going to submit your project to Google Classroom, and I think most of you got the kinks out of the way, and I think we got most of the project today. We've got some questions as people were working on a week 1 project about supported file types. So for the images, which are backdrops and sprites and costumes, the supported types are JPEGs, PNGs, and SVGs. And if sound for the sound effects are WAV and MP3 files. And if you don't have those file types, if you have something else that you really want to use, you can use, there are different software that you can use to convert them. A really easy one is Zanzar.com. It's online. You can upload it's free. You don't need to sign in or anything. You just upload a file and punch in your email, and once it's done converting, it just sends you an email with the download link. So it's really simple. So you can definitely use some of those to convert. And once again, this is the same slide we used last time, but plan before you begin. Test as you go. You always want to test little bits at a time before you build the whole program, especially with motion. You want to kind of test one frame at a time, so make sure one piece of the motion is working before you move on to the next one. There are always multiple ways to get something done. This is especially true for motion. There's so many different motion commands, and you can pick and choose, and you don't have to use the same one each time.
Absolutely.
And again, don't be afraid. It's not going to break.
Yeah, definitely not going to break.
It's not going to break, so feel free to play around, explore different commands, and even some of the commands that we haven't talked about, feel free to explore them.
even explore some of the programs, remix some of the code,
Right.
see how things work.
Oh yes, so the studios that I've shared. So the teacher projects are available right on here. This is the week 1 assignment link, but I'll also put this link on the week 2 assignment as well. So you can see other people's project and take a look at what everybody have been doing. And if you go into the About page, under Course Resources, we have a link to the example studio, which contain all the examples that we've shown so far and more, and all the ones that we will be using. So this was Nick's example from last week. We have the bee and the Zeus that we just showed today, and the magical turkey that we showed today.
Can explore the tricky
This, I think the flowers we showed last time.
Right.
The New York City slideshow is another one that kind of relates to this week's project that uses all the motion icons in the backdrop. You can look at the scripts. So by default, it opens up the project page, but you can click on See Inside, and actually you'll see the script. And you see a lot of the things that we already use. So we have the go to, the movement, wait, show and hide, and the say and the think and the sound. So it's really comprises of all the components that we've already talked about.
Right.
So you'll see how the scripts are done. It's just a little bit longer because it's a longer program.
Right.
And absolutely, as you can see in this, there are 5 or 6 sprites, but you can sometimes, it starts with Sprite 5, ends with Sprite 8. You can change the name of a sprite. Runa, if you could go in there, and then just in the info, you can go in and change the name of the sprite.
So right-click, go into info, and you can change it to something that makes more sense.
Absolutely, absolutely. And you can see that there are 11 backdrops. It's up to you how you change and modify things. So keeping it flexible, that's a good way.
So I think we have covered everything we need to cover today.
Let us know if you have any questions. Email or email me, Nick, or if you you can also leave them in the stream in Google Classroom.
Yeah. Next week we'll be back on Monday. Hopefully no more snow day at 4 o'clock.
Right.
And we'll be looking forward to getting more projects.
Right. Yes. Play around, scratch around, integrate more Scratch.
Right.
Thank you.
All right.
Have a good one, everyone.
Bye-bye.
Thank you. Bye-bye.
Thanks for tuning into our webinar. If you learned something new, give us a thumbs up or leave us a comment down below in the comment section. And if you're looking for more DLT videos, click on one of the videos on the left side of the screen or explore our YouTube channel. And don't forget to subscribe.